Next one is the skewed distribution. What is skewed distribution? What is skewed distribution? It exhibits a longer tail on one side. There are two types of skewed distribution. The left side skewed distribution and right side skewed distribution. In the case of right side skewed distribution, we call that, it is also known as positive skewness. It tells us, it indicates a longer tail on the right side. It will be something like this. I'll just show you instead of drawing it. So this is the one. Look here, in this case, if you see here, you can see a longer tail here. It is something, tapering off here. It is not, going, it is not like your typical normal distribution shape, right? On the right side, it is falling down. Like from here itself, it started falling down. It is tapering off. Since, we can see a longer tail on the right side, we call it as a positive skew. It is also known as what? Positive skew or right skew, right? Since since we can find the longer tail on the right side of the peak, we call it a right skew. It is also called as a positive skew. And if you see the same pattern on the left side, if you find a longer tail on your left side, that is called your left skewed data, negatively skewed data. Negatively skewed data. Okay. So as for the skewness, first of all, what is skewness? Skewness is, it will show the, the distribution or the distribution of your data set will exhibit a longer tail on one side, either on the right side, on the left side. If I have to tell you in a single word, what is skewness is all about. Skewness is a measure of symmetry. Using skewness, we can tell, it is a measure. Skewness is a measure. This measure helps us to understand the level of symmetry in your chart. Okay, so whether the given data is left skewed or right skewed, we can tell quickly with the help of skewness. We have something called skewness measure. Okay, and this is your right skewed data. And what is the normally distributed? So incomes have a smooth distribution. It is a normally distributed data. Using histogram, you can find out the distribution pattern of your data set. And also, we have something else called box plot. Using box plot, also you can find out the distribution pattern of your data. You can see that the median is there in the middle, right? Exactly. And then in the rectangle, if you see on the right side and left side of the rectangle, almost same, right? The width is almost same. And the minimum and maximum, right? And we don't see somewhere longer tail or, it's all both this, things are same. But in the real world, believe me or not, none of the data are exactly they normally distributed. There will be some kind of asymmetry will be there. If the asymmetry is too much, like if the tail is tapering on the right side abruptly, right? So that is your right skewed data. If you find any tail, longer tail on the left side of your peak, we call it left skewness. Okay, there is a question now. This is the right skewed data. In the right skewed data, which one holds true? Anyhow, I will come back to that a little later. So this is the data set, okay? Website visitors and frequency. When I plotted this data in my chart, I can see that this is a left skewed distribution, left skewed data. The data is skewed on the left side. Okay, in this case, website visitors. Yes, the website visitors, we are seeing it here. Okay, fine. And here, what we can understand with this data set, we can see that the 10 instances of having between 0 to 100 visitors to your website. And then 20 instances of having between 100 to 200 visitors. And 200 to 300 visitors are there for 30 instances. Okay. 200 to 300 customers, they visited your website 30 times. That is what it tells us. And 300 to 400 customers, they have, visited your site, the 40 times. Between 300 to 400 customers. Okay. They visited this one. Okay. That is what we can see, that the shape of the distribution, if you see on the right side, okay, here we can see that it's a left skewed distribution. It is a left skewed distribution. So this is what your peak. And if you see a longer tail on the left side of our peak, we call it as a left skewed data, left skewed distribution or left skewed data. So here we can understand that a large number of instances have a higher number of visitors, while fewer instances have a lower number of visitors. So here 0 to 100 lower number of visitors, right? Only fewer instances. But here we can see that high number of visitors. So 1,000 to 10,000 customers, they visited almost 200 times, right? Almost 200 times in your website. Okay, everything is fine. If you find a longer tail on the left side of our peak, we call it the left skewed distribution or negatively skewed distribution. If you find a tail on the right side of the peak, we call it right skewed data or positively skewed distribution. Okay, in the case of left skewed distribution, the mean is typically less than your median value, which is again less than your mode. So your mode will be there here. Remember one thing very clearly, irrespective of the distribution pattern, whether it's left skewed, right skewed, or normally distributed, the peak is your mode. Even in this case, the peak is mode here. In this case, the mean median is not equivalent to your mode. Okay, the mean is typically less than your median. So your median will be somewhere here. This is here, and then your mean will be there here. This is where your mean will be there here, and here your median will be there here. This is what your mode. This is specific to negatively skewed distribution. The mean is slightly dragged towards the left side of your median. So your median is less than your mode, and then your mean is less than your median. We can say that the mean is less than the median, and then the median is less than your mode. This is because the mean is pulled down by the lower visitors. Because you have so many lower visitors, your mean got pulled down here. Okay, so can we see outliers here? 0 to 100, we can see only 10 visitors are there, right? So we can say it's an outlier, as there are only 10 instances in this range, right? And this range is quite different from others. Here at least 20, 30, and 40, everything is fine, but this is very low here. Okay, again, you need to use the formula there, but here in this case, we have range of values. How can I find out the outlier? The simple thing is, by looking at this histogram itself, we can find out, right? This one seems to be very less, 10, 20, 30, 40, 50, 60, 50, and 100 and 200. Okay, and this one is very small compared to the rest. Hence, it's kind of an outlier here. In the case of left or negatively skewed distribution, okay, how we can understand? By looking at the frequency itself, we can understand, right? Whether it's a left skewed or right skewed. So how you can find out here? How we can make out by looking at the frequency, whether it's a left skewed or right skewed? How we can find out here? You can see that, right? It starts from, the frequency starts from very low value to high value, right? It's going to, so low value, start from low value to, it is going on an incremental way, right? Incremental way. If it is in the opposite way, let's say we say this is a kind of an ascending order. If it is in the descending order, 200 will be there, 100, that is your right skewed distribution. By looking at the frequency itself, you can tell quickly, hey, is this the left skewed or right skewed? Fine. Very good, right? So now you are able to understand what is left or negatively skewed distribution. If you find a longer tail on the left side of your peak, that is called your left or negatively skewed distribution. Okay. So with that, what kind of insight you were able to get? We could find out that there is an outlier in our data set. 10, right? 10, that is an outlier here. And the next one is how to compute the mean in the histogram. The next question is, okay, so the same thing here. So how do I find out the mean in the histogram in this case? Here we have the range of values, right? Interval. So 0 to 100, 100 to 200. How can you find out the mean in this case? And here also we can see that the interval, if you see 0 to 100, 100 to 200, 200 to 300, everything is fine, but here suddenly 1000 to 10,000 is there. Computing the mean from this kind of histogram is a little bit tricky because the bins are having unequal width here. So here the equal width, 100, 100, the width is 100, right? 100 to 200, the width is 100, and 200 to 100 is 200 to 300, the width is 100. But here suddenly 1000 to 10,000, the width is unequal here. Ideally, it should be equal, the width. So, but the common approach is we use the midpoints of the bins. Right? So we will use the midpoints of the bins as representative values for our range, for that range. Okay. So in this case, we need to identify the midpoints of the bins. Okay, this is very important. Look here. They will ask you this one also. Even you believe me or not, there are some data scientists, they don't know this one. How to compute the mean in the histogram. Okay, so this is the data set. How will you find out the mean here? So you need to find out the midpoints for the bin. What is the midpoint here? So 0 to 100. Okay, 0 plus 100 divided by 2 is your 50. That is the midpoint. Okay, similarly, you need to find out the midpoint for 100 plus 200, 300, right? 100 plus 200 divided by 2, 300, 150. This is what your midpoint. Okay, and 200 to 300, what is the midpoint? 250 here. Here 700, and then in this case 350, 450, and here 1500, 750. In this case, how much you will get? You get midpoint is 5,500. Am I correct? Right? Okay. The next step is you need to multiply this midpoint by the frequency. In this case, the frequency is 10, right? So 50 into 10, which is nothing but 500. And 150 into 20 is how much? You get 3,000. And here 250 into 30 here. 250 into 30 is 7,500. And then 350 into 40 is equivalent to, sorry, here 300, right? Not 350. Sorry, 350, correct. 350 into 40, 1400. And then here into 50, and here into 100, here into 200. So this one gives me 22,500. This one gives me 75,000. This one gives me how much? 11. Okay, something like that. So this is what the value we got it. First, the step one is you need to identify the midpoints. Identify the midpoints of the bins. This is your bin, right? Identify the midpoints of the bins and then multiply each midpoint by frequency, the corresponding frequency. And then you need to sum all these value, 500 plus, and finally you need to sum all this value, 500. This is step 3. In step 3, 500 plus 3000 plus 7500 plus up to this 11 followed by 5 zeros, right? And here you will get how much? You will get 1227. Let me, I'm just checking my calculator. Okay, fine. This is the one. In step 3, this is your total weighted sum. This is your total weighted sum. Okay, and the next one is step 4. In step 4, you need to find out the total frequency. Total frequency. How much we get total frequency? Can someone add this and tell me? 300 and 350 and 400. Yeah, 450, right? We get 450. Am I correct? 450. Step 4. And then in step 5, here the estimated mean. We have to tell always estimated mean. Okay, this is not the exact mean. The estimated mean is equivalent to the total weighted sum divided by total frequency. Total weighted sum divided by total frequency. Got it? This is how you will have to find out. You can compute the mean in the case of histogram. In this case, it is not like 100, 200, 300, 400. It is not a single value. It is an interval. In this case, you need to compute the midpoint for the bin. Step 1. Step 1. Compute midpoints for the bins. And step 2. What is step 2? Multiply each midpoint by its corresponding frequency. Step 1, compute the midpoints for the midpoints. Midpoints, you need to add these two values divided by 2. Midpoints, okay, for each bin you need to find out, and then you need to multiply each midpoint by the corresponding frequency. Step 2, and step 3, you need to add all the values. After you multiply the midpoint value by the frequency for each and every value, whatever you get the value, right? When you add all the values, you will get the total weighted sum. And in step 4, you need to compute the total frequency and total weighted sum divided by total frequency, your estimated mean. So in this case, how much are we getting at? The estimated mean is 2728. 2728. Approximately. Okay. The estimated mean number of visitors is approximately 2028. This is the estimated mean number of visitors. And now you can tell, you can do kind of an estimation with this. So, all right, it is already late now. What we will do is we will continue next session. In the meanwhile, right, you can watch the previous batch videos also. Okay. In today's session, what we discussed, before we wrap up, from my side, I'm done with that. Since you don't have any questions, I'm going to give a quick wrap up. We discussed about what is a distribution, what is the shape of the distribution. And also we have discussed about the advantages of plotting the data in histogram in terms of understanding the different types of distribution, how the different types of distribution is going to helpful. Okay, so what is the advantage of finding out the shape of the distribution? You can identify the outliers in your data set, and also you can understand whether any bias are there in your data set. In the case of normal distribution, I explained you, only few people are getting very high salary, only few people are getting lesser salary. Hence, there is no bias in the data set. Okay, so and also it helps us to understand the variability of the data, and then you can compare different populations with the with the help of the shape of the distribution. By looking at the shape of the distribution, we can compare different population. You can identify the outliers. You can identify the variability of the data, and also in the case of machine learning point of view, understanding the shape of the distribution helps us to select the appropriate machine learning model. And also we discussed about what is positive skewness, what is negative skewness. On the right side of the peak, if you see a longer tail, that is your positive skewness. On the left side of the peak, if you see the longer tail, that is your left skewed or negatively skewed data. And finally, we have seen how to compute the mean in the histogram. And importantly, we have seen how to interpret the histogram, right? How we can tell the story by looking at the distribution pattern, which you see it in your histogram. And also, I have shown you in Excel how to plot an histogram. Okay. And also, we have seen in Python how to find out the 25th percentile, 50th, the median, and the 70th percentile also. Okay, a lot of takeaways for you guys. So with this, I'm going to wrap up